Okay, boys and girls, we are going to go over the Castle Learning assignment that you did on Friday. Now, you don't have to do all of the problems, just go to the questions that you got wrong and watch the video for that portion. So we're going to get started on question number 1. It says, given the equation, find the vertex. Hopefully you remember the vertex form of an equation. We need to get y by itself. So in order to get y by itself, we're going to subtract the 7 from both sides. Once we subtract 7, we get x minus 6 squared minus 7 equals y. And remember that the vertex is the opposite of what's inside the parentheses, so it's going to be positive 6, and we keep what's on the outside. So 6, negative 7. You can always check your work by putting it in the calculator and then looking for the vertex on the table. Okay, the next one, number 2, find the answer of k to complete the square for the quadratic equation. Really, we're trying to figure out what's going to make that equation a perfect square trinomial. So in order to figure out k, hopefully you remember, we are going to take the b value, divide it by 2, and square it. So negative 6 divided by 2 is negative 3, squared is positive 9. Question number 3, if z squared is equal to 144, which could be the value of z? Now, the opposite of squaring a number is to take the square root. So if we take the square root of z squared and of 144, we're going to get that z could be equal to positive 12 or negative 12. And we have positive 12 as an answer. Okay, moving forward. What is the vertex and turning point of the equation? So there's 2 ways to do this. You could put the equation in your y equals in your calculator, or you can complete the square. Before we do either of those, I'm just going to take a look at these equations and their vertexes to make sure that they check out. So if we look at number 1, the vertex of number 1 would be negative 4, negative 26, and that doesn't even make sense for the first question, so we know that that would be out. Number 2, we should have positive 4, negative 26. That doesn't work. Number 3, we should have, well, we know that we should never have that coefficient in front of the x, so that kind of tells you that's not vertex form. And number 4, we should have negative 4 and negative 26. So without doing any work, just checking that our vertex matches with our equation, we can find the answer. So sometimes you want to just use process of elimination and you don't even have to complete the square or use your calculator. Now you can always check by putting your original equation into y1 and what you think is the solution into y2 and making sure that it checks out. Number 5, if the square root of 84 is simplified to a square root b such that a and b are integers, what is the value of a? Now all we have to do is simplify the square root of 84. So we're looking for 2 numbers that multiply to 84, one being a perfect square. Now you can check all of your normal ones, 9, 16, 25, 36, and I believe that the largest one might actually just be 4. So we have the square root of 4 and the square root of 21. So the one that's a perfect square is your 4. The square root of 4 is equal to 2. And we're at 2 square root 21. So if they want to know the value of a, they're looking for the integer that's on the outside, which here is positive 2. Okay, number 6. The expression square root of 500 is equivalent to which of the following? Again, we're going to be simplifying. So we have to think of what 2 numbers multiply to 500, one being a perfect square. You can use your calculator. Remember, in your calculator, you're going to go to that y equals screen. So you would do y equals 500 divided by x, and you would look at your table to see, the 2 numbers that are going to multiply to be 500. So in your table, hopefully that you see square root of 100 and square root of 5. 100 being your perfect square, so that becomes 10 square root 5, and your answer is number 3. Okay, number 7. What is 2 square root 45 expressed in simplest radical form? So remember that this is really just 2 times the square root of 45. So we're going to bring the 2 down, kind of let it just hang out on the side right now. And we're going to more focus on the square root of 45. Now, just like the other problems, we need to figure out two numbers that multiply to 45, one being a perfect square. It ends up being the square root of 9 and the square root of 5. 9 is our perfect square, so we get 3 square root 5. And the only thing is we can't forget about the 2 that we had hanging out over here, so we're going to bring the 2 back. And we have 2 times 3 square root 5. The 2 and the 3 are on the outside of the radical, so we can actually multiply them, and we end up with 6 square root 5, which means our answer is number 7. Number 8. I'm going to erase number 7 just so we have more room. Okay, number 8. What is 3 square root 250 expressed in simplest radical form? So we have 3. We have 3 square root 250. Same thing as before, let the 3 hang out on the side, and let's simplify our square root of 250. Now the two numbers that multiply to 250 is going to be 25 and 10. 25 is the perfect square, so that becomes 5 square root 10. 3 times 5 is 15, so we get 15 square root 10. And that's option number 3. I'm hoping that you guys are following along okay. I know that it's a little bit weird on the screen and it's kind of sloppy, but I think that you can read it. Alrighty. Number 9. When 5 radical 20 is written in simplest radical form, the result is k radical 5. What is the value of k? So just, again, similar to the other ones, we need to simplify the radical. So 5 radical 20, let the 5 hang out on the side, simplify the square root of 20, we have 4 and 5. So 5 times the square root of 4 is 2, times radical 5, and we get 10 square root 5. Now they just want to know what the value of k is. K is on the outside over here. You can see it's on that outside. So the number on the outside is 10. So that means k is 10. Okay, again, I have to erase what we just did. That's a little annoying, sorry, but we need more room. Okay, so what is square root of 32 expressed in simplest radical form? Again, same idea. Square root of 32. What two numbers go into 32? One's a perfect square. You should get 16 and 2. Square root of 16 is 4, so we get 4 radical 2. Okay. Question number 11. The graph of a quadratic is shown below. Great. What are the coordinates of the vertex of the function? So I hope that you remember that the vertex is that turning point right at the top, and the point right there would be 1, 2, and then up 2, 4, 6, 8, 10, 12, 14, 16. So our turning point is 2, 16. Answer choice 4. Okay, number 12. Which equation in ordered pair represents the correct vertex form in vertex? So before we get started on actually solving or completing the square and rewriting this equation, let's just check out our multiple choice options. So we know that we can identify the vertex when it's in vertex form by taking the opposite of what's inside of the parentheses and then keeping the number that's on the outside of the parentheses. So for number 1, our equation does match our vertex because if it's x minus 6, we know our x value should be positive 6, and then positive 43 for our y should remain. So number 1 is actually possible. But number 2, it says x minus 6, which means our x value should be positive. So this one's out. Number 3 does check out, and number 4 does not. Okay, we can go through completing the square just as a refresher. If you did get this question wrong and you tried to complete the square, we want to make sure that you know how to do it. So your first step, hold on, let me erase this to give us more room. Your first step is to get your c term to the other side. So I'm going to subtract 7 on both sides, and we get j of x. I'm just going to write y to make it easier. Y minus 7 equals x squared minus 12x. Now we want to create a new c term that's going to create a perfect square trinomial. So to do that, we take our b term of negative 12 divided by 2, and we square it. Negative 12 divided by 2 is negative 6. Squared is positive 36. So I'm going to go ahead and add that to both sides. Now, if we simplify, we end up with y plus 29 equals x squared minus 12x plus 36. Okay, now we can factor the right side of the equation. And remember, a perfect square trinomial means that the factors are the same, which will happen. We'll have x minus 6 times x minus 6 which ends up just being x minus 6 squared equal to y plus 29. And your final step to get y by itself, we're just going to subtract your 29 from both sides. And we have y is equal to x minus 6 squared minus 29, and that matches choice 3. Okay, number 13. Okay, I'm going to erase this one just because we need more space again. Number 13, in the function, the minimum value occurs when x is, that's just a fancy way of saying what's the y value of the vertex. So what we can do is state the vertex, which is 2, positive 4, and they want to know what's the x value, which is 2. Simple. Number 14, what is the vertex? So again, opposite of what's inside the parentheses, which would be positive 8. And since there's no plus or minus on the outside, the only possible value would be 0. 15, what are the roots? So again, you know roots are x-intercepts, solutions, I'm missing one. X-intercepts, solutions, roots, zeros. There we go. So also looking at the choices, they're all in simplest radical form, which tells us that this isn't going to be possible to factor. So you get to choose here if you would rather do completing the square or quadratic formula. It's totally up to you. I'm going to do completing the square. If you chose quadratic formula, go ahead. So again, first step is to add 20 to both sides. And we get x squared minus 10x equals 20. Create that new c term, which is negative 5 divided by 2 squared, 25. Add it to both sides. We end up with x minus 5 squared on the left and 45 on the right. Now we are solving, which means we want to get x by itself, so we're going to keep going. We need to undo this square. The opposite of squaring is square rooting. So we square root both sides. On the left, what's inside the parentheses drops out, so we have x minus 5 equals positive and negative square root of 45. We keep going, and we need to get the x by itself, so we add 5 to both sides. And we get x equals 5 plus or minus square root of 45. Now, if you simplify the square root of 45 on the side, you should get x equals 5 plus or minus 3 radical 5. And our answer is choice 3. Okay, number 16, what are the roots of the equation? For this one, we can see that our answer choices are square roots, so we know that we can't factor. I'm also noticing that our b term is an odd number, which would make it a little more difficult to complete the square. So the best method of solving 16 would be to do the quadratic formula. So first we need to write down what the quadratic formula is, and if you remember, that's great, and if you don't and you had to look it up, that's fine as well. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We should identify our a, b, and c values. So a is 1. There's nothing in front of that x squared. B is negative 9, and c is positive 5. So we take all of those, we substitute it into the formula, and we get x equals negative 9 plus or minus the square root of negative 9 squared minus 4 times a times c. Whole thing is over 2a. Now remember, we put what's inside of the square root into the calculator. So that ends up being negative 9 squared minus 4 times 1 times 5, and that should be 81 minus 20, so that is 61. So we end up with x equals positive 9 plus or minus the square root of 61 over 2. And luckily, we do not have to even go any further because we see that that is option choice 1. 17, what is the possible root of the equation? Same idea. Let's first see, can we factor it? Nope, we have simplest radical form, so we can't factor. Can we do completing the square? That would be very challenging because our b term is odd, which tells us we need to use the quadratic formula again. Now it's listed right there above. So we want to use that same formula, but we have different A, B, and C values. So we have A is now 1, B is now -3, and C is now -6. So again, substitute it into the formula. X equals -3 plus or minus the square root of -3 squared minus 4 times 1 times -6 all over 2 times 1. Okay, simplifying. We have +3 plus or minus the square root of 9 plus 24, so we end up with 33. Here, and that should be all over 2. Again, we didn't even have to simplify because that answer is here. So +3 plus or minus, so either one of those would work, and over 2, it seems that 2 is our answer. Question 18, the roots of x squared minus 5x minus 4 equals 0 are. So looking at our choices, we have 2 that are integers and then 2 that aren't. So I'm going to go ahead and start by factoring this quadratic because it may be factorable. So I'll see if it is. So we have x squared minus 5x minus 4 equals 0. We want to find 2 numbers that have a sum of -5 and have a product of -4. So 2 numbers that multiply to -4 and add to -5. So that would be -4 and -1. They both add to -5. Oh, but they do not multiply to -4. So that one is not our answer, actually. So I can go ahead and erase that. So I do not think there are 2 numbers that multiply to -4 and add to be -5, which means that it is not factorable. So as you can see, I try and factor it also, and if it doesn't work, then it just doesn't work. And you can go ahead and choose one of the other methods. Now, again, your B is odd, so completing the square wouldn't be the best. We're going to do quadratic formula. So I'll write it out again. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. A equals 1, B equals -5, and C equals -4. So let's substitute those in. We have x equals -5 plus or minus the square root, -5 squared minus 4 times 1 times -4, all over 2 times 1. We get x is equal to 5 plus or minus the square root of 25 plus 16. So that would be 41 all over 2. And we can see that that is our choice number 2. Number 19, again, we're finding the solutions. Our B term is -8, so I'm going to go ahead and do completing the square since our B term is even. Now they already moved the C over to the other side for us, so we don't have to do that first step, but we do have to make this a perfect square trinomial. So we're going to add 16 to both sides, and we get x squared minus 8x plus 16 equals 20. X minus 4 squared equals 20. We can square root both sides since it's the opposite of squaring. We get x minus 4 equals positive and negative square root of 20, and continue to get our x by itself. Now the only thing left to do is to simplify that radical, so I'll go over here. 2 numbers that multiply to 20 is the square root of 4 and the square root of 5. Square root of 4 simplifies to 2 square root of 5. So we just have 4 plus or minus 2 square root of 5, and that is choice number 4. Okay, moving along, we have number 20, which is very similar to question number 19. So really, you're just going to go about that exact same process, and your answer is 1. Question 21, which equation has imaginary roots? Now, if an equation has imaginary roots, that means there's no real roots. So this takes you back to discriminant. We're going to find the discriminant and then look for whichever one equals a negative number. So first we need to get them all in standard form. So the first one, we can distribute the x. We get 5x plus x squared equals 8. Subtract our 8 from both sides and we end up with x squared plus 5x minus 8. We have a is equal to 1, b is equal to 5, and c is equal to negative 8. If we substitute those into the discriminant formula, which is b squared minus 4ac, we end up with 5 squared minus 4 times 1 times negative 8, which is 25 plus 32, which is going to be a positive number, so number 1 is not correct, or that one's not the one that has imaginary roots. The second one, again, we do the same exact process. I'll change the color for you. We have 5x minus x squared equals negative 3. Add 3 to both sides. We'll get x squared plus 5x plus 3 equals 0, which means a is 1, b is 5, c is 3. b squared minus 4ac. 5 squared minus 4 times 1 times 3. Again, not going to give us a negative number, so I'm going to cross that one out. I'm going to erase a lot of this because I need more room, so just bear with me. Okay, let's do 3 and 4. So question number 3 is x squared plus 6x equals negative 10. Add the 10 to both sides to get it equal to 0. And that means we have x squared plus 6x plus 10. A equals 1, b equals 6, and c is 10. b squared minus 4ac. And we have 6 squared minus 4 times 1 times 10. 6 squared is 36 minus 40. That's going to end up being a negative number. So since our discriminant is negative, there's going to be no real roots, and we call those imaginary roots. Next question. Which statement must be true if a parabola represented by the equation does not intersect the x-axis? Now remember, your x-axis are solutions. They're all real solutions. So in order for you not to have a real solution or not to have a root or an x-intercept, that means that your discriminant is going to be negative. Since b squared minus 4ac, all of these are representing what your discriminant is, the only possible option is number 2, showing that the discriminant is negative. Okay, question number 3, given the 2 quadratic functions below. So we have the one function over here, which is f of x, and the second function on the right side, which is g of x over here. And we want to compare them. So there's 3 things that we're looking at. We're looking for the vertex, the zeros, and their axis of symmetry. So let's go ahead and find all 3 of those for both of them. So the first thing we're looking for is the vertex. On this left side, our vertex should be 2, positive 4. And over here, our vertex is 2, positive 4. And remember, we have that pattern going on over here, which is how we find our vertex. Okay, so those are the same. Number 2, they have the same zeros, so we have to check those out. Our zeros on the left side, we're actually going to have to either put it into our calculator or we're going to have to put it in standard form and then factor. So I'm going to find the right side first for the simple fact that it's easier to find. So remember, your zeros are when the y value is 0. So here's one of our zeros, and here's one of our zeros. So that's where x is 0 and x is 4. And then the third thing is your axis of symmetry. So our axis of symmetry is just the x value of the vertex. So it's x equals 2. And of course, this one is x equals 2. So before I find the x values, your zeros of the left side, the f of x, I'm just going to kind of cancel some things out on our multiple choice. So obviously 1's not an option because it says 1 only. And 3 is not an option because it says 2 and 3. So now we're just figuring out, is 2, do they have the same zeros? So what you would want to do here is go into your calculator, go into y equals, and do x minus 2 squared plus 4. Now either you are looking at your table or you're looking at your graph, but you notice, hopefully, that there are no zeros and that this function doesn't cross the x-axis. So that means that number 2 is not the same. So we know their roots are not the same, which means our answer has to be option number 2, which is 1 and 3 are equal. Question number 4, find the vertex for the quadratic and tell if it's a maximum or minimum. So your vertex, again, same way we do every other one, it's the opposite of what's inside, so -2, and whatever it is outside. So we can cross out option 1 and option 4 and option 3. So it looks like number 2 is our answer.